So for solving these, step 1 is you draw the object. Step 2 is you label all the forces. Step 3 is you draw the direction of the acceleration or the net force. Step 4 is you find the net force. Step 5 is you solve for gravity if you need it. So if you need gravity, then you solve for it. And then number 6 is you find the missing forces or the object's acceleration. And again, be careful with direction. Okay, so number 1. Box experiences an applied force to the right of 7 newtons, a friction force of 4 newtons. What is its acceleration if it has a mass of 3 kilograms? Okay, so we start off by drawing a box on the ground. Okay, so far so good. Then we draw the forces. We know there's applied force to the right. It tells me there's an applied force to the right of 7 newtons. We know there's friction. Friction is always against motion, so we're going to draw friction left. And it tells me that's 4 newtons. We know that there is a normal let's start with gravity. We know there's a gravity force down because there's always gravity acting on objects, but it does not tell me what that is. And we know there's a support force against gravity, and that's called the normal force. And if you're sitting on a surface, you're always going to have a normal force. So if you're sitting on a surface, you're always going to have a normal force. Okay, so that takes care of drawing the object. That takes care of labeling the forces. Now we're ready to draw the direction of the acceleration. So the acceleration is always the direction of the net force, and the net force is the direction of the unbalanced force. So it doesn't say anything about normal and gravity, but what I know from this other practice is that usually normal and gravity are the same. Here's 3 and 3. Here's 3 and 3. We said on this one, F and H were equal to each other because the net force was to the right. The net force was left, so E was 300. They're usually balancing each other out if we don't know what they are. And that's the case again here. They're balancing each other out because we don't know what's going on. So the unbalanced forces are right and left. There's more force right than there is left. So all I have to do is draw an arrow to the right and write A next to it. And that's my acceleration. I don't know what the value is, but I know it's to the right. Okay, then I find the net force. This is where we jump down to the bottom of the page and we look at the 2 equations that we have. So the 2 equations we have are F net equals MA and F net equals F1 plus F2 plus blah, 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 blah. And if you're saying to yourself, well, what are these equations? We haven't seen these equations before. Sure you have. In this first one, you did F1 plus F2 equals the net force. Okay? F1 plus F2 equals the net force. So you've done that before already in number 1. And in this one, we had the net force, and given the mass, we could find the acceleration. Or if we had the acceleration and the mass, we could find the net force. So all we're doing is either combining the mass and the acceleration to find the net force, or adding the forces together to find the net force. But we're doing one of those 2 things. So we look at the problem and we say to ourselves, so do I know the acceleration and the mass, or do I know the net force or the forces acting? Well, I do know the mass, it's 3. I do know the acceleration is to the right, but I don't know what the value is. So because I don't know what the value is, I can't use F net equals MA. But I do know the forces acting on it, 7 and 4 in the opposite direction. So what I can do is I can find my net force by doing the forward plus negative backwards. 7 plus negative 4 is 3. See? It's that easy. It's that easy. Okay? And there's no, like, gotchas coming on. Like, some of the problems get a little trickier, but there's not, like, a 2D motion thing where it's like, oh, you do this, and then you do the triangles, and then you do this other thing, and then you do this third thing. It's just find the net force however you find it. I found it to be 3. Okay. Solve for gravity if you need it. I'm not dealing with anything up and down, so I don't need to solve for gravity. It doesn't ask me for it. However, I'm going to show you how to do it real quick so that you can do it later on. It's very easy. Gravity is Fg equals mg. All you have to do is multiply mass times g, which is 9.8. So if I wanted to find the force of gravity, all I had to do is take the mass times 9.8. $29.4. Which means if that's what the force of gravity would be, the normal force would also be 29.4. Now, I didn't ask you to solve for those here, but it's just helpful to see how you would find them if you need them. Okay, so we're on to 6. Find the missing forces or the acceleration. I'm finding the acceleration. So I used F net equals F1 plus F2 plus blah, 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 which means now to find the acceleration, I'm going to use the other equation, F net equals ma. So F net is 3 equals the mass, which is 3, times the acceleration, a. Divide both sides by 3. You get a equals 1.